Okay, so this is our first day of review for the final, and I am not going to go over every single thing we've ever done. It would take forever. So I am going to hit some of the highlights, and you really should take some notes. Just write on this document, on this review thing. I wouldn't make a separate thing for notes, but some thoughts, things that you haven't talked about in a long time. Stuff on the inside is horizontal, so horizontal on the inside. To me, that's enough of an abbreviation. I'd remember it from high. And what do you think I'm going to put on the outside? It's going to be vertical on the outside. So I'm going to put VO. Vertical on the outside. And that's also this. So that means when they ask you, like, what happened to this thing? It got moved 5, and I would put this underneath it. 5 left. 4 up. Because vertical is up and down, right? And that's a vertical stretch. Are these ringing a bell? We did have a test on this a long time ago. So, welcome, sir. Find this it's the top one in the review folder. All right, so if I had to graph this, your best friend in graphing is, well, first off, it'd be really handy to know this is a V shape that has been moved all these places. How would you know it's a V shape? Well, there's certain graphs you're supposed to know in precalc. This one is the V shape. Okay, the absolute value graph. It's kind of a shape of a V. So it would start like this, and then it moves all these different ways, like 5 to the left, up 4, and vertical stretch of 3. But honestly, I wouldn't graph it that way. I'd make an XY chart. Everybody put an XY chart next to it. And now which numbers should I pick? This is not just blindly picking. I would pick something that makes the inside 0. Like what, when I put it in here, in the middle of this function, what would be a good number to start with? Tell you know. What would make this part 0?
-5.
Yeah, so that's a good thing to start with. So, -5. Does that make the whole thing 0? No, it makes the inside 0. And then you go 3 times 0 is still 0, but then you add 4 at the end. Final answer would be 4. So my graph for sure has the point -5, 4 on it. And then, if you haven't learned this already, you go on either side of it. Remember this from a different unit? We go on either side of this point. There's probably a point on either side of that point. So we stick in -4 and 6. Everybody take a second. Figure out what happens when you stick -4 and -6 into this function. Chart. Good. Pop it in the backpack. You're not using it. Codes are going around. Okay, Mason, what'd you get when you stuck in -4? Okay, I'm going to help you. -4 goes here. What is -4 plus 5?
1.
Then you absolute value it, and it's still 1. And then, this 3 here.
Times by 3, which is 1, and then plus 4,
Wait.
which is 3,
3.
and then plus 4.
There you go. So 7. Who else had 7 for that one? Okay, good. Garrett, what'd you get when you stuck in -6?
7.
Weird. But not really weird if you realize this is a V shape. So it should do that. So -5, 4. -4, 7. Huh. Interesting. Look at that. It almost like it has like a slope of 3. See how that 3 kind of acts like a slope in front? Makes sense to me anyway. All right. Now I'm going to graph that last point, -6. 7 is like there. And so look at that. It's a V shape. Goes like this. And has it been shifted to the left? Yup. Has it been shifted up? Yup. And the fact that it's steeper than a normal V shape is because of this 3 stretch factor. Okay, all of these could be done that same exact way. Basically, you just really need an XY chart. And you need to be smart about how to start. Always start by making the inside 0. So Iris, what's a good number to stick in here?
-2.
Yep. And then once I figured that out, I'd put in -1 and -3 because this thing that makes it 0 on the inside is a good place to start, and then you need points around it. All right. Now, I'm going to not do all of these, and you're not going to have to do all of them either. So please come with me to this part, piecewise functions. We haven't done that in a while. This is on the 3rd page. You definitely have a piecewise function on your final, and it's really not that hard if you think of it as 3 graphing problems on 1 graph. So this is my function, and it's 3 separate problems. I'm going to circle this one and just think of them as one at a time. F of x is equal to x. That's basically saying y equals x. That's just a straight line with a slope of 1, and it would go through 0, 0. That's just y equals x is just this line right here. But why am I not going to graph this line all the way through like that? Because it only exists when x is less than or equal to -2. So I'm going to erase this up to there. Now, I just kind of slapped it on there, so I'm not exact on exactly where my points are. But why did I erase almost all of it? Because it only exists when x is less than -2. Here's where x is -2. So on that side of the line, that's where that function exists. So what I would do is make the XY charts, but this time you know that you should start with -2 and only go less than that. See how it actually is kind of handier in a way? Because they tell you what to start with for x. All right, so if I stick in -2 into what? Well, into this function right here, y equals x. F of x is like y equals x. So if I take y equals x and I stick in a -2, it would go right there, and then it must be -2. And -3, you'll catch on to the pattern pretty quick, must be -3, -4 must be -4. And now I graph and actually make sure those points are right. Now my line was just kind of slapped in there, but it was close. -2, -2 is right there. -3 is right there. -4 is right there. All right. Next, this graph, which I'm going to circle in green, that only exists between -2 and 2. See right at the end there? So I'm going to say now, I'm changing this black line to a green line. This graph only exists in there. In between those, we're going to graph x minus 3 squared minus 5. I need an XY chart. I'm going to stick in what numbers? Well, it says right here, between -2 and 2. So, -2, -1, 0, 1, and 2. Now, one thing. Do you get that this says that the x is not 2, it's less than 2? So this is really important. This spot and this spot, I'm going to put a little knot next to it. Do you remember that? That means it goes right up to it, but it doesn't touch that spot. So we're going to stick in -2, but it says that our x has to be bigger than -2. So we go right up to it, but we don't actually get to that spot. So when I put in -2 here, that's going to be -5 squared is 25. 25 minus 5 is 20. It would touch 20. Well, I can't even graph 20. It's off my graph. It's like way, way, way up, beyond 10. So -220 is not super helpful. So I guess I'm going to go do the next one that I can actually maybe graph. I'm going to stick in -1. -1 in here makes -4. Negative 4 squared is 16. 16 minus 5, 11. Now, at least I can get close to graphing that one. It's like right there. How about if I stick in 0? 0 minus 3 is negative 3. 3 squared is 9. 9 minus 5 is 4. 0 comma 4. All right, and I can tell from looking at this thing that it's a parabola. Because, you know, it's got squared in it. It's a parabola, but I can't really see the parabola because I only can see between those two green lines. So I really have to trust my chart. Now I'm going to stick in 1. 1 goes in here. One minus 3 is negative 2. Negative 2 squared is 4. 4 minus 5 is negative 1. 1, negative 1. That's like right there. So there is my graph, and I guess I better do this last point because it goes right up to 2, but it doesn't touch 2. So I'm putting a 2 in here, and that's going to be negative 1 squared is 1. 1 minus 5, negative 4. It's heading right there. So what do I do in these spots that it doesn't actually touch? You put an empty spot there. And this one goes so far off the graph that you'd make an empty spot up there, but we can't even see it. All right. So if you had to do this one, if it was a test, you'd break it up into 3 parts and you'd do 3 separate graphs. I want everybody right this second to try this last one. Maybe make it over here. Y equals absolute value of 2x. Make your XY chart and only pick x's that are, what does it say? Bigger than or equal to 2. So then you'd start with 2, of course. Ethan T, what'd you get when you stuck in 2?
4.
Yep. Addie, what's the next thing I should stick in?
3.
And what'd you get?
6.
Yep. So 2, 4. 3, 6. If I put in 4, I'm just going to get 8. Looking like a nice straight line. And there you go. Now, last thought. You should erase out these lines that were just kind of like placeholders. They were telling me, like, only do this graph in here. And only do that graph in there. And so I'm just cleaning it up to make my final. There. You see how it's 3 separate graphs all on one graph? There's the blue ones. That was for just y equals x. There's the red ones. That was for the middle. And then there's the black one at the end, and that was for this. And there you go. So, also watch out, because when I erased and put this back in, I screwed up. This one is a solid dot. And this one's an empty dot. How do I know? Because this one says it can equal to. So then that gets a solid dot. All right, that's some pretty intense stuff from our first chapter. Our next chapter had to do with this. Everybody get to, it's going to take you a minute, find the next chapter review. Now, you don't have to do any more review than what you think you need to do. You have to take responsibility here. It's very likely that the final is going to lower some of your grades because you're not going to study for it enough, and then you'll get a worse grade than your average and it'll bring you down. That's just reality. But those of you that take this seriously and try, you do your homework that I'm showing you and check it against the key, you'll do fine on the final. I mean, it's a review. You've done all of it before. So, but it is up to you, and I just really hope that you decide that for this next few days, that you're going to take this seriously and review for this test. And if you do, you can raise your grade with your final. Some kids will do that. It all depends on how seriously you take it. All right, everybody split this into two equations. X plus 5 is 14. And it's really common for people to think you put the negative on the left side. You do not. X plus 5 equals negative 14. Notice they look identical except that one got a negative. And that's how you solve these. They're really easy if you draw the two equations right. So final answer. 14 minus 5 is going to be 9. Negative 14 minus 5 is going to be negative 19. There's my two answers. And if you're ever like feeling like, is this really right? We'll take the 9, stick it in, see if it works. Absolute value of 9 plus 5, it is 14. Sweet. And negative 19 also works when you stick it in right there. All right. How do I solve this one? What's my favorite saying? If you can, come on, you can do it. If you can factor it, you should. So factor it. And then each little part gets set equal to 0. If you can stay with me for just literally 3 more minutes, we'll be done reviewing. And then I'll give you your test back. Okay, so just stay with me for 3 more minutes. You can do this. Since this is positive and this is negative, that tells me about my signs. I know by using logic, I have to have one negative in it to make this be negative. But I have to have 2 negatives to make that come out positive. See how I could know that it was minus and minus? And then, Iris, final answer?
X minus 3 and X minus 1.
Yep, because those two multiply to that. And when I do the whole thing out, the outside and the inside, makes negative 4x. Cool. Factoring's nifty, but it's not the answer. Brady, final 2 answers. Yep. Because that's what makes this equation equal 0. If you wanted to prove it, you could go stick in, I'll just stick in the 1 just because this should be super easy to check. And I get 1 minus 4, which is negative 3, plus 3 is 0. Cool, it works. All right. So then you just get to this kind. And a lot of kids struggle on this kind, and I totally understand why. If I'm going to try to solve this, I got a square root in there, and I got this add 3. That makes it even harder. If this wasn't here, I would just square both sides. Do you get how squaring this would get rid of the square root? But it's got this plus 3 there. All right, so here's your steps. Subtract 3 from both sides. Start with that and catch up to me. I'll wait. Now, number 8, subtract 3 from both sides. If your hand's not moving, then you're not touching it. Yes, you try to push it open with your elbow or something. Okay, so now we're going to square both sides. Notice how I put a parenthesis around that. You don't just square one of the numbers randomly. Math's not like that. Just pick one and square it. No, you got to square the whole thing. So that really means x minus 3 times x minus 3. And squared does take off square root. And all you have left is 2x minus 3. Now from here, you'll have to set your quadratic equal to 0. And then if you can factor it, you should. 9 times out of 10, we make them factor. So once this is all multiplied out, you'll probably subtract 2x from both sides. And then add 3 to both sides. You can do a double step if you want. Double step. And that'll clear out this stuff so it's all equal to 0. And then once you got your quadratic equal to 0, I bet you could factor it. All right, so there's some help on that kind. This page is where they get greater or equal to 0. Now, we just did this. Everybody go to number 11, please. On a recent test, we just had this. So this should be fresh in your mind. Bontius, what do you think we should do first? Yes. So we factor it. Can you just tell me one thing? What do I start with? What do I start with? Mm-hmm. And then just tell me one thing. What signs should they be?
Positive.
Yeah, got to be positives. And that brings us down to the only thing left, which is like, what should I use to make a 9? There is 2 choices. Garrett, what do you think we should use? 9 and 1 or 3 and 3? What's your best guess? You are correct, sir, because this and this together will make it the 10x, which is what we wanted. Yay. Now, remember, though, that when this has a greater than, it's like the tip of a number line. Do you remember this deal where now you got to test the intervals around it? We just had this on our most recent test. And what about -9 itself? This number right here, does it work? Well, if I put in -9, it makes the equation equal 0. I want it to equal 0. It works. And so does this one. And then I just got to test whether or not it works like out here. So I put in 0 and I see what I get. And when I put in 0, I end up with 9. Is 9 bigger than 0? Yes, it is. So it's working here. And that's just a reminder. I'm not done. You have to finish it. But we've done these so many times. All right, what would I do here? First off, always get your quadratics equal to 0, and then always factor them. So I'm going to add 50x to both sides. And then I'm going to factor it. There's an x in everything, and I bet you'll be able to factor it again. And then I bet you can make a number line. And you'll have 3 numbers on your number line. Don't forget the 0 for this one. And then you test around those intervals. Okay. We've made it to the end. I've reminded you how to do 2 whole chapters of stuff. Do I think that everybody in here remembers everything? No. But if you have individual questions now, you'd have a chance to ask me at the end of class. So what are we going to do for the rest of the hour? Well, I'm going to hand you back those tests that you guys took. Anybody that has not taken it, I'll have you come up here and we'll talk about when you're going to take it. And I'll have you step in the hallway with your iPad so you can be working on some review while we look over those tests. So if you have not taken it, why don't you come on up with your iPad. We'll talk about when you're going to take it. And that's what we do for the rest of the hour, and that's all I got for the video for today.